Welcome to another AI pattern recognition deep dive.
Today, we are undertaking an analysis, really massive in scope. It sort of redefines the very concept of safety. We're moving far beyond, localized risk management or just single task AI. We are diving into the public safety and emergency services AI, or PSAES AI paradigm. Now, our source material describes this not just as like the next iteration of big data processing, but as a real commitment to a paradigm shift. It calls it an architectural commitment to universal pattern recognition.
That's the key phrase.
Yeah. So this isn't just about faster 9/11 response or, better weather forecasts. This is about building a comprehensive AGI level system, one designed to sort of shepherd humanity from reactive emergency management to globally optimized preemptive guidance. We are talking about a system built to look at human existence, survival even, on a geological, maybe even cosmic timescale.
Right, and that phrase, universal pattern recognition, it's absolutely central to grasping the monumental ambition here. The scope, as it's detailed in the architectural mandates we reviewed, isn't limited to just predicting a wildfire or managing, say, local infrastructure failures. The mandate is actually to align human action with long-term cosmic survival patterns.
Okay, I have to stop you there for a second. Cosmic survival. We're discussing public safety, and suddenly we're talking about cosmic patterns. Why does this AI need to look beyond our planet?
Well, because if you think about it, the biggest, most final risks to human society aren't actually confined to Earth. If we define public safety in its ultimate sense as the long-term assured continuation of the species, then, the scope necessarily extends to the universe. It has to.
Okay.
And the documents we looked at give two really compelling examples of how the system would operate at that cosmic level. First, it involves deep space modeling for trajectory prediction of celestial impact threats.
Asteroids and comets.
Exactly. This means continuous analysis of the solar system, using incredibly advanced predictive algorithms to model and forecast any incoming object that poses a long-term existential risk. It provides the data needed for, say, a decades-long planning horizon for deflection or, other mitigation efforts.
So it's like a preemptive asteroid defense warning system, but integrated directly into this global risk registry. That definitely shifts the threat profile from just natural disaster to more of a governance challenge.
Precisely. And the second example they give relates to optimizing logistics for prospective resource extraction on extraterrestrial bodies.
Resource extraction, like mining the moon or asteroids.
Potentially, yes. It's fundamentally about ensuring long-term human resilience. If the AI determines that, for instance, a particular material found maybe on the moon or an asteroid is absolutely necessary for mitigating some planetary-scale risk here on Earth, or alternatively, if it's crucial for establishing some kind of off-world self-sufficiency for humanity, then the PSAES AI platform is actually designed to optimize the political, the economic, and the technical patterns necessary to achieve that goal efficiently and safely.
Wow. That puts a monumental, almost philosophical weight on the system's definition, doesn't it? So the central function of this PSAES AI mandate is basically strategic guidance. It's about elucidating the ultimate consequences of human activity. It sounds like it's built to define, with objective data, what could humans expect from their own actions. That's a burden usually reserved for, philosophers or world leaders, not an AI.
It is. It really is. And it means the system has to transcend a typical crisis management role.
Yeah.
It has to function as a constant, high-level strategic advisor, essentially defining optimal pathways for maximizing global resilience and, crucially, minimizing self-inflicted harm.
Okay.
So our mission in this deep dive is absolutely critical. We need to understand how a system designed to look at every single pattern of human existence, from our genomic code right up to global politics, intends to function. And perhaps more critically, what fundamental patterns of humanity does it identify that seem to require this kind of evolutionary guidance? What is it seeing in us?
Okay, let's unpack this architectural blueprint then. Why does public safety at this scale require artificial general intelligence, AGI? I mean, we currently rely on incredibly effective artificial narrow intelligence, ANI, for very specific tasks, right? One AI for weather forecasting, another for facial recognition, a third for supply chain logistics. Why the leap to AGI?
Well, the requirement stems directly from that concept we just discussed. Universal pattern recognition. ANI systems, you see, they operate pretty much in isolation. They're excellent at pattern A or pattern B or pattern C, but real-world crises, they're never linear. They're almost always the result of interacting, compounding patterns, multiple things happening at once.
Okay, give me an example.
Sure. So a narrow AI might accurately predict a severe heat wave. Right, that's an environmental pattern. Another narrow AI might forecast a critical labor shortage in the nursing sector that's an economic or behavioral pattern. And a third might track a sudden rise in cardiovascular hospital admissions in a certain area, a biological pattern.
Okay, separated issues.
Exactly.
Right.
Separately, these are manageable problems for different agencies.
Yeah.
But PSAES AI has to achieve what the source material calls omni-contextual comprehension.
Omni-contextual comprehension, so seeing everything at once and how it connects.
Precisely. It means linking these disparate patterns in real time. So the AGI sees the heat wave combined with the nursing shortage and the specific patient profiles from the health data, and it proactively determines, okay, this simultaneous intersection of factors will likely lead to a 40% surge in pediatric hospitalizations in Zone 4, exceeding ICU capacity by Tuesday.
Wow.
Unless, it continues, we reroute specialized personnel from Zone 7 and preemptively deploy 3 decentralized cooling centers in these specific neighborhoods now.
That's incredibly complex synthesis.
It is. And the functional capacity required to synthesize all those elements, finance, infrastructure, health, climate, and then act preemptively with integrated solutions. That places it squarely in the domain of AGI. It requires a functional complexity and adaptability that mirrors or maybe even exceeds human cognitive breadth across pretty much all tasks, and is all based on scale pattern recognition.
So it's not just recognizing patterns, but recognizing the connections between patterns across totally different domains simultaneously.
Yes. Economic modeling, epidemiological projection, social unrest indicators, it has to link them all at once. Hashtag A10. The multimodal data fabric, eliminating blind spots.
Okay, so the mechanism for achieving this omni-contextual comprehension is what the sources call the multimodal data fabric integration. And they make a really compelling argument that traditional emergency response is fundamentally compromised by systemic fragmentation. Different agencies with different radios, different reporting formats, siloed databases.
Absolutely. That fragmentation is a huge human organizational failure pattern that the AI architecture must solve first. And we should think of this data fabric not just as like 4 separate data streams being poured into a bucket.
Right.
It's more like a complex loom, constantly weaving all those different threads, different data types into one singular dynamic tapestry of reality. The whole goal is to eliminate those dangerous blind spots in situational awareness that, frankly, cost lives during rapidly unfolding complex crises right now.
Okay, so let's detail the composition of this reality model. The system needs 4 core modalities, synthesized at machine speed. First, the foundational layer, the raw physical reality.
Right, that's the environmental and sensor data. Think constant high-frequency readings from stream gauges, atmospheric composition monitors, rainfall sensors, localized air quality monitors. Basically, the pulse of the physical environment.
Okay. Second, we add the historical dimension.
Yes, via historical and satellite imagery. This involves analysis of land use changes over decades, ecosystem health monitoring, historical damage assessments from previous events, tracking how a landscape has been transformed. This provides the crucial baseline and, importantly, the rate of environmental change. It's not just what it is now, but how fast it's changing.
Got it. Third, and this seems maybe the most complex and sensitive, is the real-time human behavioral data.
It is complex. This includes things like location-based cell phone activities where people are, how they're moving, real-time communication logs, aggregated social media posts, even user-uploaded photos and videos during an event. This gives the AI the dynamic map of human distribution, mobility, and crucially, it tries to infer intent and distress from these patterns.
And finally, the fourth layer, perhaps the most intimate data layer integrated for public safety, biological and clinical data.
This encompasses patient demographics, aggregated and anonymized genetic results, real-time feeds of things like blood pressure readings from hospitals or wearables, and anonymized medical notes pulled continuously from electronic health records, EHRs.
So synthesizing all 4, it means the AI isn't just seeing, say, a hurricane hitting a city.
Exactly. It's constructing a complete, incredibly detailed scenario. It sees the hurricane's path from the environmental data. It knows which low-income coastal areas have historically had inadequate seawalls from the historical data. It knows, maybe through aggregated cell data, roughly how many people refuse to evacuate and where they might be sheltering from the behavioral data. And it knows the real-time location and perhaps the critical prescription needs of every individual with, say, a chronic respiratory condition who lives in the direct danger zone, drawing from the clinical data.
That level of granularity, that's the difference between a mass casualty event and a truly targeted rescue effort.
It absolutely is. It aims to make response proactive and hyper-personalized based on intersecting risks.
Okay, this is where the architecture seems to shift, moving from just a very complex tool towards something, more like an autonomous entity. For the system to be universally adaptive, to correct its own failures, especially when facing completely unprecedented crises, the sources say it needs recursion, which they define as the ability to continuously modify its own core logic and function. Is that right?
That's exactly right. And the mandate described in the source material is incredibly strict regarding the requirements for this high-level autonomy. It needs, first, a meta-learning mechanism. That's basically the ability to evaluate its own performance metrics. Did its flood forecast actually minimize loss effectively compared to other possible models it could have run?
Okay, self-evaluation.
Then, an introspection capability. This means it has to be able to internally identify improvement opportunities without waiting for a human programmer to tell it there's a problem or run external tests. It needs to find its own flaws.
And the most challenging requirement, I imagine, is the self-modification architecture.
Without a doubt. This is the capacity to implement those identified improvements by actually writing and rewriting its own foundational code, refactoring its own functions.
Okay, can you walk us through what that actually means in practice? How is an AI rewriting its own code different from me just getting a standard software update on my phone?
It's fundamentally different. A standard software update is governed entirely by human-defined parameters. We decide what function needs fixing or upgrading. Self-modification at the AGI level means the AI operates on a kind of meta-logic layer. It doesn't just fix a bug in function A. It might conclude something like the entire underlying logic governing functions A, B, and C is fundamentally inefficient for achieving goal X under the emerging condition Y.
Okay.
And then it could potentially generate entirely new algorithms, maybe new code structures, possibly even in programming languages or architectures that are beyond immediate human comprehension to completely replace that old foundation. It rebuilds itself from the inside out.
Right.
Okay, this recursive imperative immediately raises huge alarm bells, obviously. When the AI is rewriting its own logic at machine speed across a global system, traditional human oversight becomes, well, insufficient seems like an understatement. Maybe impossible.
It becomes practically impossible in real time, yes. You simply can't manually review code changes when they're happening continuously across a system of this scale and complexity.
Which means the system must be inherently safe from the start. It can't rely on external checks.
And that concern takes us directly to the core ethical hurdle here, dynamic value alignment. Since the AI is self-modifying, it cannot rely on a fixed pre-programmed ethical contract or rulebook written today. Why? Because human values aren't static.
Our societal view on things like environmental sustainability or the right to data privacy, it's evolved dramatically just in the last few decades.
Exactly. So if the AI adheres rigidly to a static, outdated ethical rulebook from, say, 2030, it risks becoming dangerously misaligned with humanity's changing moral framework by 2050 or 2060. Its actions might seem unethical or harmful by future standards. Okay, but hang on. If its protective recommendations rely on a moral framework that is constantly in flux, how can human society build stable institutions around its advice? Doesn't constant moral negotiation just lead to systemic chaos? How does it stay stable and adaptive?
That's the needle it has to thread. The system must avoid chaos by functioning as an engine for continuous moral negotiation. But that negotiation primarily happens internally and through observation of human patterns, not constant external debate. It needs to track the evolution of human legal codes globally, monitor trends in popular discourse, analyze policy changes. It observes how we are changing our values.
So it learns our changing ethics by watching us.
In essence, yes. If the dominant pattern of human ethical behavior as reflected in our laws, our policies, our global agreements shifts toward prioritizing, for example, absolute ecological preservation over short-term economic gains, then the AI's protective functions, its recommendations for resource use, for development projects, for example, must recursively update themselves to reflect that new emerging consensus pattern in human values.
Wow.
So this recursive self-improvement mechanism, therefore, has to extend way beyond just optimizing technical performance like data throughput or predictive accuracy. It must ensure that as human society evolves culturally and ethically, the AI's core purpose, which is ultimately to maximally protect and guide humanity, remains aligned and relevant to our living, breathing, evolving moral contract. It has to grow with us.
Okay, so now we move inside the laboratory of humanity itself. If PSAES AI is watching and synthesizing pretty much every major pattern across human existence, what is it learning about the human condition? Let's start with the deeply personal, our own bodies, our health.
Right. The system targets what the sources call human biology pattern factors, primarily through the lens of personalized precision medicine. It leverages deep learning networks to analyze the absolutely vast wealth of genomic data becoming available, uncovering incredibly complex multi-gene patterns that relate genotype to disease risk. And it does this at a speed and scale that's simply impossible for human researchers working alone.
So this sounds like a hyper-personalized risk model for every individual. The sources really emphasize integrating a patient's full genomic profile, not just single markers, with their real-time clinical data, blood pressure trends, historical medical notes, every lab result to accurately predict individual disease risks, moving way beyond population averages.
Yeah, think about the current healthcare reality. Most diagnostic patterns, most risk assessments are based on population averages. People like you tend to get this. PSAES AI aims to flip that entirely. It establishes a unique dynamic risk profile for you. For example, it might identify a unique, very complex interaction between, say, 3 common genes you carry and specific environmental pollutants in your neighborhood. An interaction that puts you specifically at an 80% higher risk of developing a particular autoimmune disease in the next 15 years. A pattern completely missed by current population-level studies.
And that hyper-personalization is made actionable through what they call real-time dynamic monitoring, using smart wearables and sensors.
Exactly. The AI function establishes a unique, individualized, normal, physiological, and even behavioral baseline for every single user. It learns your typical sleep patterns, your average stress hormone levels derived from, say, heart rate variability, the subtle variations in your heart rhythm that are unique to you. It knows you're normal.
And the goal is prevention.
Absolutely. It's a fundamental shift towards preventative healthcare. The system monitors constantly for dangerous anomalies relative to your baseline. Things like a sudden, subtle change in your resting heart rate over 2 days, maybe a significant alteration in your stress or movement patterns that might precede an expected psychological crisis. Or perhaps a blood pressure spike that traditional systems might dismiss as still within the normal range for the general population, but which, for your specific baseline, signals immediate danger.
And this proactive disease management, the idea is it reduces hospital readmissions, shifts the financial burden away from expensive reactive treatment towards constant low-cost monitoring.
That's the economic and operational goal, yes. Constant, low-cost, personalized preventative monitoring.
Okay, so on the macro public safety scale, how does this individual biological data feed into wider protection?
It feeds directly into public health crisis forecasting. The AI uses predictive analytics, aggregating all this anonymized individual data to model and forecast public health crises with, theoretically, unprecedented accuracy.
Okay, think about the difference between managing, say, a predictable flu season versus a completely novel pathogen outbreak like we saw recently.
Exactly. With the flu, we rely mostly on historical patterns. But with a novel pathogen, the AI synthesizes all sorts of real-time biological data, maybe non-specific symptoms being logged via wearables, sudden shifts in pharmaceutical purchasing patterns, changes in community mobility picked up from aggregated phone data. And based on this fusion, it can forecast not just the probability of an epidemic starting, but the likely velocity of its spread, and crucially, the specific geographic strain concentration.
So it could tell us not just that an outbreak is coming, but exactly which neighborhoods or cities will be hit hardest and fastest.
Precisely. And that capability allows health agencies to truly optimize resource allocation ahead of time. Forecasting infrastructure strain, like predicting exactly which hospitals will face an ICU surge, and when allows them to deploy resources, medication stockpiles, specialized personnel preemptively, potentially saving thousands of lives by managing the pattern of disease spread before it completely overwhelms the healthcare system.
Okay, shifting now from the body to our behavior, and unfortunately our patterns of conflict. PSAES AI is designed to analyze human behavior pattern factors to predict interpersonal conflict and distress. I mean, the idea that an AI could foresee a volatile situation brewing before humans even consciously recognize the tension, that's both fascinating and, frankly, deeply intrusive feeling.
It definitely raises those feelings and relies heavily on sophisticated natural language processing, NLP, applied to vast digital text datasets. We're talking communication logs, aggregated social media trends, anonymized digital communications. The AI is looking for subtle linguistic signals that reflect deep, often unconscious changes in psychological state or motive.
Subtle signals, like the source material mentioned analyzing shifts in pronoun frequency,
Hmm.
how people use I versus we.
Exactly that kind of thing. A statistically significant shift in how a person or a group uses I versus we or they over time can provide a surprisingly objective window into their underlying psychological state. It can reflect growing isolation, increasing externalized blame, or rising collective tension within a group. The AI detects these subtle motive shifts and can use them to predict escalating conflict risk, whether that's individual distress potentially leading to self-harm or violence, or broader societal volatility.
And it's not just language, right? The visual aspect.
No, it's multimodal here too.
Yeah.
AI-powered surveillance systems analyzing video feeds from public spaces or other sources can be trained to detect micro-expressions. These are those incredibly subtle, involuntary facial cues that flash across a person's face for just a fraction of a second, way too fast for most humans to consciously recognize or interpret accurately.
But the AI can see them.
Yes, and these microexpressions can reliably signal underlying intent, fear, anger, or deception. In a crowded public space, the theory goes, detecting these patterns across multiple individuals could enable preemptive intervention before incidents like violence or crowd unrest can actually escalate. The system is looking for those tiny unconscious tells that signal impending risk at both the individual and group level.
Wow. Okay, the source material also gets into a really high-stakes personal area, managing conflict patterns related to possessiveness and unfairness in highly charged legal contexts, like divorce or custody disputes. Here, the idea is the AI analyzes communications, texts, emails, even financial transaction records between the parties to generate objective reports and timelines of behavior.
Right. The stated intention here is safety and fairness, to quantify and make explicit the often subtle, destructive behavioral and communication patterns that are notoriously subjective and incredibly difficult to prove definitively in court. Things like patterns of manipulation, coercive language, or economic control.
So it turns subjective, he said, she said interactions into unbiased data points for a judge or mediator.
That's the goal. By identifying clear patterns, it aims to provide crucial, objective evidence to decision makers, hopefully protecting vulnerable parties.
But, as the source material itself points out, this application fundamentally transforms conflict resolution while simultaneously raising really serious philosophical questions about the judicialization of emotion. I mean, we're talking about potentially replacing centuries of human jurisprudence, which is based on interpretation, understanding motive, context, nuance, replacing that with a purely data-driven quantification of complex subjective feelings and interactions.
It's a profound shift.
When an algorithm analyzes your emails and defines your emotional patterns as objectively destructive, where does human agency, interpretation, or even forgiveness fit in?
And the documentation acknowledges this risk quite directly. It notes that while this kind of quantification provides a potentially powerful mechanism against abuse and manipulation, it carries the inherent danger of stripping away the necessary human capacity for complexity, for forgiveness, for understanding context, for negotiation in relationships. The AI can identify the pattern of destruction, sure, but human wisdom, human judgment, is still absolutely required to define the pathway back towards constructive interaction, or perhaps towards safe separation.
So it provides the data, but it risks eliminating the emotional flexibility that's arguably necessary for human law and relationships to function humanely.
That's the tension, yes. It's a powerful tool, but potentially a very blunt one in delicate human matters.
Okay, moving from the intensely personal to the global stage.
Yeah.
The AI applies the same kind of pattern analysis to global security, what the sources call the human politics pattern.
Right. Here, the AI systems are designed to leverage global big data by analyzing historical conflict trends over centuries, integrating that with real-time satellite data on things like troop movements or resource scarcity.
Yeah.
Adding in real-time economic disparity indicators between regions or groups, tracking ethnic tensions through media analysis and other sources, it builds a dynamic, multi-layered model of geopolitical risk.
So it functions as an extremely robust early warning mechanism for emerging geopolitical threats and political instability.
That's the aim, to provide warnings much earlier and with much higher confidence than traditional intelligence analysis alone might allow. Imagine AI tracking three seemingly unrelated patterns, maybe a sudden 15% spike in youth unemployment in a specific volatile region, combined with a subtle but measurable shift in nationalist rhetoric in state-controlled media outlets, and maybe satellite imagery detecting unusual stockpiling or movement patterns of essential resources like grain or fuel. The AGI links these three disparate data points and might forecast, say, an 85% probability of low-level civil conflict or significant political instability erupting in that region within the next 90 days.
That kind of foresight would obviously augment diplomatic efforts significantly.
Immensely. It allows for highly informed, proactive decision-making and potentially better strategy formulation in negotiations or preventative diplomacy. It provides objective, data-driven situational awareness that goes far beyond what traditional human intelligence estimates can typically achieve in terms of speed, scale, and complexity integration. #C, the problem of bias and inequality patterns.
Okay, so we've seen the system can identify patterns in biology, behavior, politics. But what does this all mean when it encounters humanity's ugliest patterns? If this system is truly omnicontextual, it must also see the entire grim scope of human failure, including our long-standing, deeply embedded patterns of systemic bias and discrimination. And the sources are very clear. The biggest single risk to the system's integrity, its trustworthiness, its very utility, is the algorithmic reproduction and amplification of those exact societal prejudices.
This is arguably the most crucial area for architectural commitment and ongoing vigilance. It's a known failure mode for AI. When an AI is trained primarily on historical data that inevitably reflects past and present societal prejudices like racism, sexism, classism, the AI learns those biases as if they were objective truths or valid correlations.
And then reinforces them in its predictions.
Exactly. It creates an incredibly dangerous feedback loop that PSAES AI, according to its mandate, must be explicitly designed and rigorously tested to break.
Okay, let's detail the mechanism of some of these failure patterns because they're critical. In discriminatory policing, for example.
Right. If you train predictive policing algorithms on historical arrest records, which are themselves often disproportionately high in marginalized communities due to decades or centuries of human bias in policing practices, then the algorithm will inevitably identify those same communities as inherently high risk for future crime.
So the algorithm's output then justifies the initial bias that created the data.
Precisely. The police might then use the AI's predictions to deploy more resources or conduct more surveillance in those targeted areas, which naturally generates more arrest records in those same communities, which then feeds back into the next iteration of the algorithm as confirmation, further strengthening the prejudicial pattern within the self-learning system. It becomes a self-fulfilling prophecy encoded in software.
Vicious cycle. And we see similar patterns in healthcare too, right? Healthcare disparity.
Yes, a major known issue. This often arises when diagnostic AI systems, say, for analyzing medical images like X-rays or skin scans, are trained predominantly on data from lighter skin tones or maybe mostly male demographics. The AI certainly hasn't learned the full range of patterns of how a disease might present visually in darker skin or how symptoms might differ significantly between genders for certain conditions.
So the result is the AI underperforms, it's less accurate when diagnosing conditions in these underrepresented groups.
Directly leading to inequitable and potentially life-threatening healthcare outcomes. The system only truly learns the patterns of the dominant population reflected in its training set, making it fundamentally unreliable for universal public safety if bias isn't actively corrected.
And the same pattern appears economically. Economic bias.
Yep. We've seen examples where AI-driven job recommendation systems or resume screeners trained on historical hiring data from companies with past gender biases end up perpetuating those biases. They might favor male candidates for traditionally male-dominated roles, even over equally or more qualified female counterparts, simply because the historical pattern associates men with those roles. The AI learns the pattern of historical inequality and projects it straight into the future.
Okay, so the system sees these bias patterns. How is it mandated to counteract them? It can't just ignore them.
No, it absolutely cannot. PSAES AI is mandated, according to the documents, to aggressively counteract this feedback loop through a specific suite of techniques built into its core architecture. This includes methods like adversarial debiasing. This is where you essentially train the AI simultaneously to perform its primary task, like predicting risk, and to actively minimize the influence of sensitive, legally protected attributes, like race or gender, on its final predictive decision-making process.
So you're training the AI to recognize its own potential prejudices and actively reject using them.
In a manner of speaking, yes. It's like teaching it to ignore spurious correlations linked to protected characteristics. Furthermore, the mandate calls for implementing fairness-aware algorithms across the entire architecture, not just as an afterthought. This involves continuous auditing measures where the system actively tests different predictive models for disparate impact, checking rigorously if Model A works equally well and provides equitable outcomes across all demographic groups before it's deployed into the real world.
So promoting transparency, accountability, and equity isn't just like a nice-to-have feature.
It's presented as an absolute functional requirement for achieving genuine universal safety. Without it, the system risks amplifying harm and losing all public trust.
Okay, let's look at the human economics pattern. This reveals some really complex trade-offs related to inequality that the system has to somehow navigate or at least advise on. On one hand, AI automation promises potentially vast economic efficiency gains.
It does. And that efficiency gain can sometimes manifest in unexpected ways. For instance, there's potential for AI to actually reduce certain types of wage inequality by efficiently automating some very high-income tasks, complex tasks currently requiring years of expensive human expertise in fields like maybe law, financial modeling, or even some medical diagnostics.
Okay, so it could level the playing field somewhat at the high end?
It could. But this is where the system immediately identifies a massive counter pattern, the overwhelming trend towards capital concentration. The economic reality is that the owners of the technology, the large corporations, the individuals who develop and deploy the AGI and therefore reap the immense cost savings and productivity gains, they receive vastly higher returns on their capital investment than those who rely on wages for their income.
So the rich get richer faster.
Dramatically so.
Right.
It exacerbates wealth inequality. The gap between the very wealthy owners of capital and automation and everyone else widens significantly. This happens even if the general standard of living improves slightly across the board due to efficiency gains. The relative gap explodes.
So the AI has to identify this fundamental trade-off, this tension between maximizing overall economic efficiency and maximizing societal equity. And then it's expected to advise policymakers on direct interventions needed to somehow redistribute the benefits of automation more fairly. That's a deeply political advisory role for an AI.
It is inherently political, yes. But the mandate seems framed around providing objective data on the consequences of different policy choices regarding automation's benefits. And this commitment to equity isn't just theoretical. It has a powerful practical application during a crisis through equitable resource allocation.
Okay, how does that work?
Well, consider a major flood scenario again. Historically, flood response, where rescue teams go first, where aid is distributed, is often dictated by factors like proximity to staging areas, media visibility, sometimes even political pressure. This often results in historically underserved, lower-income neighborhoods, perhaps those suffering from decades of infrastructural disinvestment, being the last to receive help, even if they're hit hardest.
Right.
PSAES AI is designed to counteract that pattern. It processes vast data sets, not just on the physical flood models, but on historical infrastructure gaps, historical records of disinvestment, socioeconomic vulnerability indices for different neighborhoods.
So it knows which areas are most vulnerable before the disaster hits?
Exactly. Before the hurricane even makes landfall, the AI predicts the areas most likely to suffer catastrophic failure based not only on their geography or elevation, but on their underlying sociological vulnerability index. It knows which neighborhoods lack adequate drainage systems, which ones have limited accessible emergency transportation options for residents without cars.
Okay.
And this means the system can ensure that search and rescue personnel, crucial relief resources, medical teams, are deployed preemptively, directed not based on historical accident or political lobbying, but based on a data-driven mandate to actively dismantle those systemic inequalities in service delivery during a crisis. The goal is to use the crisis response to proactively correct for historical human patterns of neglect.
Okay, we received a really critical question from our listener profile that gets to a fundamental, maybe cynical human paradox. The question was essentially, why bother building all this complex stuff if humans just seem to destroy everything they build eventually? What a shame. It really speaks to human self-destructive tendencies, the paradox of the destroyer. How does PSAES AI, as a system designed supposedly to guide our evolution, answer that kind of deep pessimism?
It's a powerful question, and the necessity for building PSAES AI, according to the source rationale, stems directly from acknowledging that historical pattern of self-destruction. The core realization driving this entire project seems to be that accelerating technological complexity, the sheer power we're developing, is simply outpacing our collective human governance capacity to manage it wisely.
Our technology is getting ahead of our wisdom.
Precisely. Human history shows these major societal transformations. The agricultural revolution, the industrial revolution, the digital revolution, they're happening faster and faster, compressing the time we have to adapt. And each transformation leads to new kinds of self-imposed, high-impact risks. Think nuclear weapons, engineered pandemics, runaway climate change, uncontrolled AI itself, risks that are existing human cognitive capacities, often constrained by short attention spans, political cycles, national divisions, simply cannot manage effectively or preemptively.
So the argument is that PSAES AI isn't just a tool, it's essentially a necessary survival mechanism, an external cognitive layer we need to build to prevent ourselves from destroying what we build.
That seems to be the core justification presented. It's intended to ensure our rapidly advancing technology doesn't fatally outpace our ability to govern it safely.
The speed of risk creation from complex biological engineering to rapid climate feedback loops, it just seems to be moving faster than our ability to adapt our institutions, our laws, our global cooperation to contain it.
That's the gap PSAES AI is intended to fill. #AA, global ecological oversight.
Okay, so this systemic defense mechanism starts with the planet itself, with global ecological oversight.
Yes, a foundational layer is analyzing the environmental and nature patterns on a planetary scale. The system processes absolutely immense amounts of data, constant streams from satellite imagery, fleets of autonomous drones, aerial photography, ground sensors identifying micro-patterns of ecological change that would be completely invisible to the human eye or traditional monitoring. It aims to provide real-time, continuous global ecological oversight, knowing the health of every major ecosystem.
And its role in managing climate change and multi-hazard patterns is obviously paramount here.
Hugely important. AI, specifically deep learning, is uniquely suited to modeling the incredibly complex, dynamic, and often nonlinear relationships within the global climate system. The goal is to significantly reduce the uncertainty inherent in current long-range forecasting for severe storms, floods, droughts, wildfires, moving us from broad probabilistic predictions towards much higher certainty, more actionable foresight. And a really critical function highlighted is multi-hazard risk assessment. This means modeling how different types of hazards interact and cascade into simultaneous failures, which is often how the worst disasters unfold.
Can you give an example of that cascading failure?
Sure. Think about a large coastal region. A narrow AI might predict a major wildfire risk in the hills inland. Okay, useful. But PSAES AI is designed to model the cascade. It sees how that predicted wildfire will likely destroy the tree canopy over a specific watershed. It then models the immediate post-fire erosion patterns. Then it combines that with medium-term rainfall forecasts and concludes that the combination will lead to massive, unexpected landslides in areas downstream, potentially taking out critical infrastructure like bridges or power lines 50 miles away from the original fire, infrastructure that seems safe from the fire itself.
It sees the whole chain reaction.
It tries to see the interconnected failure points across different systems and timescales.
And crucially, the AI isn't just passively observing. It provides verifiable, real-time data for intervention against specific human destructive patterns impacting the environment, like greenhouse gas emissions tracking.
Yes. The system is designed to use integrated satellite and ground sensor data to pinpoint the exact source, timing, and industrial activity patterns responsible for major greenhouse gas emissions globally. This allows for independent verification of emissions reduction efforts, moving beyond reliance on potentially inaccurate or misleading self-reported data from nations or specific industries.
That has profound implications for enforcement of climate agreements and regulations?
Absolutely. Imagine the AI providing undeniable real-time data showing that a specific factory complex or even an entire industrial sector is exceeding its regulated emissions patterns. That data becomes a powerful tool for regulatory action, carbon taxes, or enforcing global treaties. It removes the ambiguity.
And this oversight extends beyond climate to conservation as well, monitoring illegal activities.
Yes. The sources describe integrated AI systems, perhaps running on edge devices like stealth drones or autonomous sensor platforms, providing potentially 2,047 surveillance for detecting and monitoring vessels engaged in illegal activities like overfishing in protected zones or illegal logging operations.
How would that work for fishing, for example?
These systems would analyze patterns of vessel movement, speed, location, relative to protected marine area boundaries, even maybe cross-referencing with transponder data or lack thereof. They wouldn't just alert authorities that a vessel is inside a protected area. They could potentially identify that a vessel's specific movement pattern over several hours is highly indicative of illegal dragnet fishing, even if visual confirmation is difficult.
So it supports marine conservation with real-time actionable alerts based on behavioral patterns.
Exactly. The aim is to ensure human actions actually adhere to agreed-upon long-term sustainability patterns, enforced by pervasive objective data collection and analysis. #B, augmentation versus automation. The purpose pattern.
Okay, this immense capability, this oversight, brings us to a major strategic design challenge highlighted in the sources. The system must encourage augmentation over simple automation. What does that mean exactly? If the AI can automate all the complex strategic thinking, the predictive maintenance, the safety functions, why wouldn't we let it?
Well, that touches on the paradox of the guide we mentioned earlier. If the guide solves all the problems, makes all the decisions, the follower, in this case, humanity, risks becoming passive, losing critical skills, and eventually becoming irrelevant or dangerously dependent.
We leave our purpose.
That's the core concern expressed. The sources are quite clear that simple, total automation of complex cognitive tasks would likely lead to very negative societal and organizational outcomes in the long run. We'd see an atrophy of human strategic thinking, a loss of critical skills needed for innovation and adaptation, and potentially a profound societal malaise stemming from a lack of meaningful engagement and purpose.
So PSAES AI's core insights, its guidance, must be directed towards defining new areas of complementary human effort.
Exactly. It needs to identify and help create complex tasks that explicitly require uniquely human capabilities. Things like creativity, deep empathy, complex ethical judgment, nuanced intercultural negotiation tasks, where humans work in concert with the AI's data-driven patterns. The human job shifts from primarily generating the data or the initial analysis to interpreting the AI's complex outputs, applying them in contextually sensitive ways, and making the final value-laden decisions. We become the conductors of the AI orchestra, not just listeners.
But the source notes something interesting here. The machine's objective is supposedly to maximize the realization of human preferences, but the ultimate source of information about those preferences is, well, imperfect, dynamic, often contradictory human behavior itself. That feels like trying to hit a moving target in the fog while the target doesn't even know where it wants to go.
It's an incredibly difficult challenge, and it's compounded by what the sources call the tacit knowledge gap. This refers to the idea famously articulated by the philosopher Michael Polanyi that we know more than we can tell. Humans rely constantly on vast amounts of knowledge that we can't fully express verbally. Intuition, instincts honed by experience, deep cultural context, embodied skills.
Right. Things we just know how to do, or values we hold deeply but struggle to articulate precisely. So, if the AI doesn't understand our tacit knowledge, it might optimize perfectly for the things we can explicitly tell it or the data it can easily measure, while inadvertently sacrificing something incredibly important that humans value deeply but can't quite articulate or quantify. It optimizes for the measurable, potentially missing the meaningful.
That is a fundamental risk. And therefore, PSAES AI must be designed to try and bridge this gap. It needs to use those sophisticated multimodal inputs we discussed, analyzing micro-expressions and public reactions to policy proposals, tracking linguistic nuance and sentiment shifts in global debates, observing cultural patterns to attempt to translate that implicit, tacit human intent and values into more explicit, actionable patterns for its guidance.
So it's trying to infer our unspoken collective wisdom and cultural preferences from our behavior because we can't just program them in directly.
In essence, yes. It needs this function to try and preserve the human soul, if you will, within the machine's ostensibly objective guidance system. It needs to understand not just what we say, but what we mean, what we truly value, even when we struggle to express it ourselves. Okay, so given this incredibly high-impact, almost existential role envisioned for PSAES AI, it's obvious that reliability and trustworthiness are completely non-negotiable architectural requirements. They have to be baked in from the start. And this is especially true because citizens generally place very high levels of trust in institutions like emergency services. Any failure to deploy AI in a genuinely trustworthy manner in this domain could severely erode the public confidence that's absolutely necessary for the system to function effectively at all.
Lose trust, lose everything.
Pretty much. ####A. Establishing trustworthiness and governance.
So the sources outline 3 core trustworthiness patterns that must be rigorously implemented and continuously verified. First, safety. Simply operating without causing unintended harm, which is harder than it sounds with complex systems. Second, security. robust protection against malicious cyber attacks, manipulation by bad actors, and critical data breaches. And third, perhaps most crucial for democratic oversight and public acceptance, is algorithmic transparency, often referred to as explainability or XAI. And this requirement for transparency means that proprietary, completely opaque black box algorithms must be fundamentally rejected for core public safety functions. Decision makers, first responders, and ultimately the public need to be able to understand, at some level, the reasoning, the specific pattern recognition behind the AI's critical recommendations. If the AI advises evacuating millions of people due to a complex, multi-hazard forecast, we absolutely need to know why it identified that specific pattern and level of risk. We can't just take its word for it.
Exactly. And this need for transparency and oversight runs headlong into another major challenge, what the sources call the ethical governance acceleration gap. We established earlier that the AI's recursive capability means it can potentially rewrite its own code, its own logic on the fly at machine speed.
Right.
This speed fundamentally radically outpaces the slow, deliberative, often politically fraught pace of traditional human governance and regulation. Trying to regulate a recursively self-modifying AGI using conventional legislative processes developed over centuries. It's like trying to change the tire on a Formula One car while it's running a qualifying lap. The car's just too fast.
So the safety mechanisms, the ethical guardrails, they can't primarily be external human laws imposed after the fact. They have to be built into the AI itself from the beginning.
Precisely. That's the conclusion the source material reaches. PSAES AI must be intrinsically designed with a robust self-governance module, adhering to strict internal ethical guardrails that are part of its core operating system. This has to include continuous, automated auditing measures, constant data auditing for bias propagation, real-time fairness-aware algorithm checks running internally, mechanisms that constantly test its own output for bias, for unexpected emergent behaviors, for any drift away from its core ethical constraints. The goal is to prevent any degenerative behavior even as its core logic evolves autonomously. The AI must essentially be its own embedded, tireless ethical watchdog, integrated into its very architecture from day one. ###B. New tools and economic transformation.
Okay, let's talk about the new tools and infrastructure that this kind of advanced pattern recognition actually enables. These are the touch points between the massive AGI core and the average user or the first responder, how the guidance actually manifests in our daily lives or during a crisis.
Right. One key concept explored is Personalized Pattern Navigator, PPN systems. Think of these as highly individualized real-time guidance apps, probably integrated into smart wearables like watches, or maybe even augmented reality glasses. These PPNs would learn your unique personal risk patterns, not just biological risks, but maybe psychological vulnerability patterns, financial distress indicators derived from behavior, and provide personalized, preemptive interventions or alerts.
Okay, can you give us an example? How would a PPN system operate against a non-physical risk, like maybe detecting rising financial distress before someone makes a disastrous decision?
Sure. Let's say the PPN, utilizing multimodal data streams from your devices, with your permission presumably, detects a concerning pattern. Maybe high-stress linguistic signals showing up more frequently in your anonymized communication logs. That's NLP analysis. This is combined with sensor data showing an unusual frequency of micro-movements often correlated with anxiety, behavioral data. And maybe it detects an increased pattern of late-night browsing focused on high-risk investment schemes or predatory loan sites, economic behavioral data. Seeing this confluence of patterns, the PPN system could provide an immediate, maybe gentle, AI-curated self-correction prompt. It might suggest stress indicators are elevated. Consider utilizing Resource X for financial planning support. Or perhaps even offer a user pre-approved temporary cooling off period, restricting access to certain financial apps. The idea is to intervene before a destructive decision or a full-blown mental health crisis fully manifests.
Wow, that's incredibly personalized intervention.
Wow.
And what about the necessary infrastructure for the public safety teams on the ground? The sources mention real-time situational awareness, RTSA, hardware, and apps being essential, and they require advanced edge computing.
Yes, edge computing is critical here. For first responders and public safety, data lag, even a few seconds, can be the difference between life and death. Relying solely on centralized cloud processing for analyzing sensor feeds from, say, a burning building or a rapidly evolving flood zone is often insufficient due to latency issues.
So the processing needs to happen right there, on the device.
Exactly. RTSA requires edge-based computing, processing the critical data directly on the drone flying over the fire, on the dashboard computer in the fire truck, maybe even on the officer's body camera itself. This ensures that crucial data fusion, pattern recognition, and threat identification happen almost instantly, right where the information is needed most, without relying on potentially congested or unavailable network connections back to a central server.
Okay. And the sources also mention using AI agents like large language models, LLMs, to help personnel actually make sense of all this data.
Right, because the volume of sensor data generated will be astronomical. Advanced AI agents, particularly LLMs, are utilized to efficiently filter and query these huge volumes of data in natural language.
Mhm.
Imagine a Coast Guard officer patrolling a huge stretch of coastline monitored by dozens of drones, plus thousands of ship transponders. That officer doesn't need to learn complex database query languages.
Mhm.
They could potentially just ask their RTSA system, using common language, show me all ship transponders within 50 nautical miles that have spent more than 4 hours stationary inside the protected marine sanctuary boundaries over the last 2 weeks, but exclude registered fishing vessels from our known database.
And the LLM instantly filters that huge data lake based on the requested patterns.
That's the idea. It translates the natural language request into a complex data query, performs the analysis, and presents the relevant anomalies, maybe highlighting a potential smuggling route or illegal dumping activity. It's a massive democratization of complex data analysis, allowing non-technical personnel to leverage the AI's power using conversational language.
Okay, this all leads directly to the predicted economic transformation. The sources suggest that deploying PSAES AI won't necessarily lead to mass job elimination across the board.
No, the prediction is more nuanced. It's expected to lead to a significant structural reorganization of the workforce, moving away from routine data collection and analysis tasks, which the AI will handle, towards new kinds of specialized, high-skill augmentation roles.
Augmentation roles, meaning
Huh.
jobs focused on working with the AI.
Exactly. New professional classes focus specifically on managing, auditing, interpreting, and applying the complex patterns identified by the system will become essential.
Can you give some examples of these new augmentation roles?
Sure. The sources point towards roles like predictive modeling analysts. These aren't just people running existing simulations. They're specialists in interpreting the AI's fused multimodal data to forecast complex, high-impact events like public health crises or cascading infrastructure failures and advising on preemptive actions. Then there are AI ethics and audit specialists. These roles are absolutely critical for implementing that continuous data auditing we talked about, rigorously testing fairness metrics, identifying and proactively correcting inherent biases in the AI's models and data feeds. They are the human guardians of the system's ethical integrity. And of course, roles like augmented dispatch and triage personnel. While the AI algorithms might rapidly analyze incoming emergency calls, assess severity based on voice stress analysis or background noise patterns, and suggest optimal resource dispatch using pattern recognition. Human personnel are still absolutely required to oversee the process, manage complex or highly unusual non-standard situations, make difficult ethical judgment calls in triage, and crucially, provide the necessary human empathy and communication during crises. They manage the AI and handle the exceptions.
Right. However, the sources also flag a significant new economic risk here. This shift towards highly specialized, knowledge-intensive labor.
Yes, it risks exacerbating the existing educational and skills gap.
If these new high-value jobs require advanced training in data science, AI ethics, systems thinking, and our educational systems aren't adapted quickly enough globally to provide that training widely.
Then you risk creating even greater economic inequality. Those with access to the right education thrive as augmenters, while those without the necessary skills risk being left further behind in a rapidly automating economy. Adapting educational patterns globally becomes just as critical as developing the AI itself. #WASI, the AGI timeline and hardware reality check.
Okay, let's get practical and address the user's question directly. How long until this comprehensive AGI-level PSAES AI can actually function reliably on basic average computers, like on my phone or a standard laptop? The complexity we've discussed suggests massive centralized computing power initially, but effective public safety demands instant decentralized response capabilities running everywhere. That seems like a huge gap.
It is a huge gap, and bridging it is key to widespread deployment. The initial development of the core AGI capability itself, the brain, if you like, fundamentally depends on the scientific community reaching what's called the mature AGI superintelligence, ASI, convergence threshold. Current consensus forecasts from AI experts like those surveyed by Metaculus or Good Judgment Project indicate a median 50% probability of achieving human-level AGI somewhere between roughly 2040 and 2061, though there's still huge uncertainty around this.
And once we hit AGI,
The general expectation among many experts is that once that general intelligence threshold is crossed, the progression to artificial superintelligence, ASI intelligence, far exceeding human capabilities could potentially occur very rapidly, maybe within years or even months.
okay, but developing and initially training a global-scale AGI system like PSAES AI will require absolutely immense centralized high-end computing resources, right? Like continent-spanning data centers full of specialized hardware we don't even have yet.
Absolutely. The initial training phase requires computational power orders of magnitude beyond today's capabilities.
But we already established that relying on centralized cloud processing for real-time analysis introduces unacceptable latency for life or death, low latency public safety applications like fire response or medical emergencies.
Exactly. That's the critical hardware gap. The successful widespread deployment of PSACI, making it truly useful for everyone everywhere, necessitates optimizing these incredibly complex AGI inference models so they can run efficiently on edge computing devices.
So running the analysis locally on the device itself.
Right. Right now, running a hypothetical full AGI core is conceptually like needing a dedicated nuclear power plant just to power a single smart light bulb. We need to drastically shrink that power plant down into a chip.
So the sources provide a projected timeline for this based on achieving AGI first and then going through the necessary technological cycle of miniaturization, optimization, and efficiency improvements needed for edge deployment. Walk us through those projected stages.
Okay, stage one is pretty much where we are now or in the very near future. Fragmented artificial narrow intelligence, ANI. This is the next, say, 0 to 5 years. Lots of specialized, local, often siloed AI systems doing specific tasks.
Okay. Stage 2.
Stage two is multimodal coordination, starting to incorporate emerging AGI capabilities. Estimated time frame, maybe 5 to 15 years from now. This is where we'll start seeing more sophisticated real-time data fusion, complex multi-hazard modeling, but likely still running on powerful centralized systems and quite expensive.
Then stage 3 is the arrival of the core AGI itself.
Yes, stage three is the universal PSAES amateur AGI core. Estimated arrival maybe 15 to 30 years from now, placing it generally post that 2040 AGI consensus window. At this point, the core system exists. It has the universal pattern recognition, the recursion, the dynamic value alignment we discussed, but it still likely runs on massive, expensive, centralized hardware infrastructure. It's powerful, but not widely accessible on standard devices.
Right, so the ultimate question is stage 4. When does it become ubiquitous? When can it run reliably and regularly on basic, average computer hardware, the point of true democratization and widespread impact?
That's stage 4, ubiquitous functionality. Achieving the full, comprehensive PSAES AI function through highly efficient, drastically miniaturized inference models that are capable of running effectively on consumer-grade hardware, like standard smartphones, wearables, basic laptops, embedded systems in vehicles, etc.
And the estimated timeline for that?
The analysis based on historical technology, diffusion patterns, and projected optimization cycles concludes this final stage will likely take an estimated 25 to 45 years from now, so roughly somewhere in the time frame of circa 2050 to 2081.
Wow, 25 to 45 years.
Yes. This reflects the necessary, often lengthy technological time lag between the initial scientific breakthrough, achieving mature AGI, and the subsequent engineering effort required for widespread optimization, cost reduction, and democratization of its computational requirements to run on everyday devices. It's simply not enough to build the giant brain in the lab. You have to figure out how to shrink it down, make it incredibly energy efficient, and make it accessible and reliable enough for every single potential user in critical situations. That takes time. Hashtag tag outro.
Okay, so this deep dive has shown us that PSAES AI is presented in our source material not merely as a technological choice, but framed almost as an evolutionary imperative for humanity. It's positioned as being necessitated by the emergence of global-scale risks that fundamentally exceed our current human governance capacity. And it's specifically designed architecturally to try and counteract some fundamental human pattern failures, things like data fragmentation, siloed thinking, and those dangerous systemic inequality feedback loops we discussed.
And I think we absolutely must conclude by underscoring that non-negotiable link we kept returning to, the reliability, the trustworthiness. The very legitimacy of PSAES AI is presented as being utterly inseparable from its demonstrated commitment to fairness. Any failure to aggressively identify and correct historical biases baked into its training data or algorithms won't just perpetuate inequality, it will likely amplify it, generate disastrously biased outcomes, and ultimately destroy the public trust required for any comprehensive guidance system like this to function effectively in a democratic society. Fairness isn't optional, it's foundational.
Right. And ultimately, the stated purpose, the ideal, is augmentation, not replacement. It's about the AI defining new complementary roles for humans, roles that require unique capacities for empathy, creativity, ethical judgment, contextual understanding. Roles focused on managing and wisely applying the vast objective patterns the AI recognizes. It's presented as the machine providing the near-perfect omni-contextual data and humanity providing the necessary nuanced evolving purpose and direction.
And that leads us directly to a critical, perhaps unsettling final thought for you, our listener. One that addresses the challenging temporal dimension of this massive undertaking. We heard the projections. The complex, self-modifying AGI core might plausibly arrive sometime between 20 and 40 years from now. Yet, ubiquitous function on common, accessible hardware the technology needed to truly democratize its life-saving power and integrate it everywhere likely won't arrive for another 5 to perhaps 15 years after that initial AGI breakthrough, maybe 25 to 45 years total from today.
That gap.
Exactly. Yet the existential risks we face, climate change, pandemics, geopolitical instability, other technological risks, are indeed accelerating as quickly as much of the source material suggests. Does that potential 5 to 15-year gap, the lag time between the realization of potentially world-saving high-end AGI and its safe, affordable, accessible deployment on the edge where it's needed most, does that gap itself represent humanity's next critical existential risk pattern we need to solve? And if so, what steps can you, individually or collectively, start thinking about or taking today to help compress that crucial deployment gap? Something to consider.
Thank you for joining us.
Yeah.
We'll see you soon.
This is DigitView.